fluids. So fluids means not only liquids. Normally we think that fluid means just liquids. Liquid and gases, both we consider fluids. First of all, you should understand. The first concept from which questions are being asked, that is density. Density. What is the formula for density? Mass by volume. Mass by volume. Correct. Its SI unit kg, volume unit per meter cube. Kg per meter cube. We denote density by this rho. Okay. What we have mixture, if we have mixture of gases or mixture of fluids, for mixture, not that mixture, for mixture, they will give one or two gases or fluids and they will ask what is the density of the mixture. So density of the mixture, see density formula mass by volume. Just here you write total mass. Total mass by total volume. Correct. Total mass by total volume. For example I am giving. There is a container. One gas is there whose mass is m1, whose density is ρ1. And there is another gas whose mass is m2, whose density is ρ2. So in a container we have two gases, two fluids. One of the fluid mass m1, density ρ1, another fluid mass m2, density ρ2. So two fluids are there. So they will ask what is the density of mixture. So what is the formula? Total mass. Total mass will be m1 plus m2 by total volume. So volume is not given, so we will calculate. See, we know the basic formula, density equals to mass by volume. From here, can I say that volume, this will go there and this rho will come here. Volume equals to mass by density. Correct? So volume of 1, how much fluid 1 has occupied? So volume of 1 will be mass of 1 divided by rho of 1 plus V2, volume of second. So mass of 2 divided by rho of 2. This way we can find the density of the mixture. Remember the basic formula, total mass by total volume. Correct? Acha. Some density value you should remember. The density of water at 4 degrees Celsius is 1000 kg per meter cube. 1000 kg per meter cube. Correct? If someone asks what is the density in gram per centimeter cube, sometimes they give in gram per centimeter cube. This is the SI unit. Sometimes they give in a CGS unit. So 1000 kg means 1 kg means 1000 gram. See, 1000 into 1 kg we can write, and 1 meter cube we can write. 1 meter is 100 centimeter. Again, 1 meter cube means 1 meter into 1 meter into 1 meter. So 100 centimeter into 100 centimeter into 100 centimeter. So see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Means it is coming 1 gram per centimeter cube. Okay. Means 1000 kg per meter cube equals to 1 gram per centimeter cube. So density of water can be written as 1 gram per cc. Cc means centimeter cube. Correct? Some more density values you should remember. density of mercury. This is 13600 kg per meter cube. 13600 kg per meter cube. So again I am saying, if they are asking from kg per meter cube to gram per centimeter cube, like this was density of water 1000 kg, in gram centimeter cube how much come? 1. So what we have to do, we have to divide exactly by 1000. Like see, 1000 divided by 1000, you get 1. So here density of mercury is 13600 kg per meter cube. If they ask what is the density of mercury in gram per cc, so divided by 1000, 1, 2, 3, 13.6 gram per cc. Divide by 1000, again I am saying divide by 1000, you will get the density in gram per cc. Then we have another term which is called relative density. Relative density, or it is also known as specific gravity. Specific gravity. What is this? This is relative density is nothing but density of any substance divided by density of water at 4 degrees Celsius. Correct. For example, they ask what is the relative density of mercury. How will find? Density of substance means density of mercury 13600 divided by density of water, that is 1000. So how much you will get? 13.6. Now one point to be noticed, that relative density, it will have no unit, because this is density kg per meter cube, this is kg per meter cube, it will be cancelled. So it is a, it is not having, it is a ratio basically, no dimension, no unit. One more thing you can observe, that relative density of a substance is basically its density in gram per cc. What was the density of mercury in gram per cc? Just now we calculated 13.6. So you can write the relative density of a substance is its density in gram per cc. Write down if you want to write. Next we have pressure variation due to acceleration. Pressure variation due to acceleration. Again, I am not going to prove, just you understand the concepts. Suppose we have 2 points. This is point number 1 and this is point number 2. And this is the direction of acceleration. Suppose in this direction there is acceleration A. Net acceleration I am writing A net. Net acceleration is in this direction. Always remember, pressure increases in the direction of acceleration. Pressure increases in the direction of acceleration. Means, if point number 1 and point number 2 I compare, which point will have more pressure? Second point. Pressure increases in the direction, and how much more? So we will write, see the pattern. Pressure at point 2 is equals to pressure at point 1 plus how much more? Rho, density of liquid, net acceleration multiplied by distance between the point. Suppose this distance between point 1 and 2 I am writing h. So distance between the 2 points, rho A net h. This much excess pressure we will have. So pressure at point 2 equals to pressure at point 1 plus rho A net h. Correct? Acha, if 2 points, there are 2 points, but no acceleration. Point number 1, point number 2. Acceleration is 0. So what we write? Pressure at 2 equals to pressure at 1 plus rho. Net acceleration is what? 0. So this term will become 0. Means these 2 points will have same pressure if net acceleration is 0. Correct? Now see, suppose we have a container and liquid is filled. Correct? This is the top level. This is exposed to atmosphere. Outside is what? Atmosphere. So this point we write pressure as P naught. P naught means pressure of atmosphere. So what is the pressure of atmosphere? P naught. Pressure of atmosphere is around 1 atm, which is almost equals to 1 bar, which is almost equal to 10 power 5 Pascal. Which is also equal to 760 millimeter of mercury, or 760 torr. Means if they give you in the question 760 torr, don't get terrified. Means they are talking about atmospheric pressure, 1 atm. Correct? If they give pressure is 760 millimeter of mercury, means if you take 760 millimeter of mercury, how much pressure it will exert? That is 1 atmospheric pressure. Okay, 10 power 5 Pascal. This is the SI unit of pressure. So what I was saying, this point of the liquid is exposed to the atmosphere. So this point is having pressure P naught. Now as we move down, suppose there is a point, suppose A, which is at a distance h, depth of how much? H. So if someone asks what is the pressure at A, if we compare P naught and A, which point will have more pressure or they will have same pressure? See, what I am saying, as you go down, is there any acceleration? Yes, acceleration due to gravity. As we go down, there is acceleration due to gravity. As we go down, we have acceleration equals to gravity. So in this direction, acceleration is there, means this point will have more pressure. So pressure at A will be pressure at the surface plus how much? What I told, density of liquid, this liquid, net acceleration, that is G, into distance between them. So pressure at A will be P naught plus rho GH. Correct? Achha, if I go to the same height but different point B, same height. Here also pressure how much? P naught. This point is exposed to atmosphere. So same pressure at B will be P naught plus rho GH. Means pressure at point A and pressure at point B will be same. And we can think like this also. If I draw a line like this between these two, if I draw a line like this between these two, in this direction, is there any acceleration? In this direction. So no acceleration means pressure will be same. So what we can write? Pressure at A equals to pressure at B. Correct? But if they specially give that we are accelerating the container or One more thing to understand like this, that suppose we are holding the container and we are running like this and we are accelerating also. Means this container we are holding and this container we have acceleration like this. This is the acceleration of the container. You are holding the bottle or container, you are running there with some acceleration. Now what will happen now? 2-3 things that you need to remember. First, if you run like this, now the shape of the liquid will be like this. First of all, the shape of the liquid will be like this. Acha, one more thing. Like if they ask, this is the point A and this is the point B. So what is the difference of pressure in point A and point B? What we have to do? Listen very, very carefully. If the container is accelerating with A, container, always understand, I don't know how many of you know this, that the fluids will experience a pseudo force in the backward direction. Pseudo force in the backward direction. Laws of motion, these things were there. If the container is moving right, the fluid will experience a pseudo force in the backward direction. So what we take now, those who don't know pseudo force and all, simple thing what you do. If they give that acceleration is in this direction, acceleration of the container, acceleration of the fluid, there is fluid inside. So acceleration of the fluid you take in the opposite direction. Understood? So whose pressure will be more? Now A. So pressure at A equals to pressure at B plus rho net acceleration, that is A, and suppose this distance is h between A and B. This will be rho A h. Okay. So pressure at the same level does not mean that every time it will be same. Here same level, same pressure. But if the liquid is accelerating, if the container is accelerating, so at the same level pressure will be different. Correct? Acha, one more type of question they ask. That this is a fluid and the fluid is kept in a lift. Okay. This fluid is kept, this container is kept in a lift. This is a lift, suppose. And the lift is going up with A acceleration. There is a point, and this kind of questions can be asked. Again, be careful. There is a point here. Here pressure is P0, suppose. At a height h, means at a depth h actually, there is a point A. They are asking what is the pressure at point A. So see how to write. First of all, you have to see in which direction acceleration is there, and the direction in which acceleration is there, that direction pressure will be more. So one of the acceleration is g downward. So one of the acceleration, if we say, so it will be g downward, the downward direction. Acha, if container is given A acceleration, if the container means lift is moving with A acceleration, the container is moving also with A acceleration. If the container is moving with A acceleration, fluid you will take what? Opposite direction. Just now I told. Means net acceleration, if I say, what is the net acceleration? So one is g in the downward direction and one is A in the downward direction. So g plus A. So pressure at point A will be P0 plus rho net acceleration, that is g plus A into h. These kind of questions they ask. Okay. See, suppose the container is at rest. This is the surface of the liquid. Its pressure will be P naught. If someone asks what is the pressure at a height or at a depth h, point A. So pressure at point A equals to P naught plus there is acceleration due to gravity, G downward direction, G in the downward direction. So more pressure will be at A. Pressure at A equals to P naught plus rho net acceleration G into H. Now this P naught is what? Atmospheric pressure. This is what? Atmospheric pressure. This extra pressure is called gauge pressure or gauge pressure, whatever you say. Gauge pressure or gauge pressure. This extra pressure. And the sum of this atmospheric pressure and gauge pressure, or you can say the total pressure. Total pressure at point A is what? P naught plus rho GH. This total pressure we call absolute pressure. Absolute pressure. Means someone asks what is the gauge pressure at A. So you will write just this term. If they ask what is the total pressure at or absolute pressure, so P naught plus rho G H. Correct. Acha, one more thing. If the container is accelerating in this direction, I told you the shape of the liquid will be like this. You can try this kind of experiments. If the acceleration of the container is in this direction, the shape of the fluid will become like this. What they ask, what is this angle? Correct. Suppose this length is from here to here, this length is L and this length is H. So can I write tan theta equals to perpendicular by base, this triangle tan theta perpendicular by base means H divided by L. And also remember tan theta equals to, this comes from derivation, I am not doing, A by G. How much the container is accelerating divided by G. Tan theta equals to A by G. Correct. Then we had Pascal's law. Not Rascal's law, Pascal's law. Okay. Pascal's law. What it says that if we have a fluid which is enclosed fluid. Okay. Suppose there is a container like this. Surahi. I don't know how many of you know. And this is enclosed. Here cover is there. Correct. At different location, different pressure is there. Suppose here pressure is 2 units. Here pressure is 4. Here pressure is 6. Here pressure is 8. Here pressure is 5. Suppose different point, different pressure. If you go at a depth h, pressure increases, no? So there is a container. Here pressure is 2, 4, 6, 8, 5 like this. If we apply extra pressure, some extra pressure, delta P, suppose 5 units, what will happen? This extra pressure will travel to all the points. Means now this pressure will become 4 plus 5, 9. The pressure at this point will become from 4 to 9. The pressure at this point will become 2, from 2 to 7. 2 to 7. 6 to 5 you have to add 11. Here 5 to 10. Here 8 to 13. Means the extra pressure will travel undiminished in all direction. Without wasted, in all direction extra pressure will be added. This application of this is called Pascal's law, that whatever extra pressure you provide, this extra pressure will travel to all the points. Its application was in hydraulic lift, which they ask in NEET exam. Hydraulic lift. So what is hydraulic lift? We want to lift a car. We give our car now for washing. They lift the car. The car is very heavy. We use this Pascal's law to lift the car. Suppose this is the car. Although it is looking like a bus, but try to manage. Suppose this is the car or any object we want to lift. What we will do, this side area we will take very narrow and this side area we will take very large area. Correct? Now if suppose weight of the car, there must be some weight of the car. Suppose weight of the car is there. Suppose this is a car, its weight is 100 Newton. I want to lift it. So how much force I should apply? 100 Newton. Then only, na? So what we have to do? We have to apply force F1. Suppose F2 I am writing, F2. This F2 should be equals to how much? Weight of the car. Then only it will lift. See what we have to do? Here we have to apply pressure. Here you have to apply small force only. See, in order to lift F2, F2 is what? Weight of the car. This is too much. This is too much. You can't lift by your hand, na? This is too much. This F2 value is too much. This F2 value is weight of the car. But see, with less force, if you apply force here, very less than this, still you will be able to lift the car. You can, I will show you. Suppose I apply force F1. This area cross section is A1 and this area cross section is A2. What I am saying, see, according to Pascal's law, you are applying extra pressure. How much? Pressure is force divided by area, F1 by A1. You are giving extra pressure F1 by A1 here. So here also extra pressure will be created. How much? Pressure is what? Force divided by area. And this pressure should be same. I told you Pascal's law. Same pressure will travel in all the points. If you provide extra pressure here, same pressure will carry forward to this point also, all the points. So this pressure and this pressure has to be same. Now see, F1 value, see, so this you have to remember. Now what you can see, F1 equals to F2 cross multiply A1 by A2. Now what I am saying, suppose the weight of the car is 1000 Newton. Weight of the car is 1000 Newton. Suppose this A2 is 100 meters square. This area is broad, this area is small. So suppose A1 is 1 meter square. 1 meter square. So can you calculate F1? How much force we have to apply? See, we will calculate F1 equals to F2. F2 is 1000 into A1. A1 is 1 divided by A2. A2 is 100. 0, 0, 0, 0 cancel. So how much force you have to apply? 10 Newton only. See, in order to lift 1000 Newton car, you have to apply only 10 Newton here. With less force, we are able to lift the car. So always remember this formula. This question is asked in hydraulic lift example. F1 by A1 equals to F2 by A2. Correct? See, some YouTube questions, not that YouTube, okay. See, so this is a YouTube device and we have two liquids, two fluids. This is fluid 1, it can be gas also. Fluid 1, this is fluid 2. Means suppose there is water, there is oil. Correct? This distance is x from here top level to here top level. This distance is x. This distance from here to here is suppose y. Correct? Always remember one point, what I told right now. At the same level, if the container is not moving, not accelerating, at the same level pressure will be same. So remember one more point I am adding. Same fluid, if we have same fluid, then at the same level pressure will be same. At same level pressure will be same. Correct? For example, see, if I say that at this level, here we have, suppose this is water, this is oil. So this is what? Oil only. And here also we have same fluid, oil. This is also oil, this is also oil, and they are at the same level. Means pressure at this point, suppose this point is A and this point is B. Means what we can write? Pressure at point A equals to pressure at point B. Correct? Achha, what you can write about pressure at point A? Suppose here this point is atmospheric pressure. It is exposed to atmosphere, na? So P naught. So pressure at A will be how much depth we are going down? X plus Y. So we will write P naught plus rho. What is the acceleration? G. Acceleration is G only, na? And what is the depth? X plus Y. This is the pressure at A. Similarly, what is the pressure at B? Here, what is the pressure? P naught. And what is the pressure at B? How much depth we are going? Y. How much depth we are going? Y. So, P naught plus rho G Y. This is another density. This is another liquid. Suppose water. So, I am writing density of liquid 1. This is another liquid. So, density of liquid 2. They can ask anything, you solve. This is the main equation means. They can ask x value. They can ask y value. They can ask what is the density of liquid value. Means this expression just you have to remember, not mug up. Just you remember, not same level, pressure will be same. Next we have Archimedes principle. Archimedes principle. See, like suppose we have a container in which water is filled, or any fluid, not only water, any fluid is there, and there is any object like this. You must have felt, if the object, any ball, deuce ball kind of thing, you put, you will feel that its weight in air. Now this deuce ball, you keep inside water in the bucket, you will feel that it becomes light. So it becomes light means there is someone which is applying force in the upward direction. Suppose weight is 100 Newton. So 100 Newton you are feeling in the air. But as you keep this ball in water, you will feel light. Means now you are feeling 60 Newton. So 100 Newton was down, means 40 Newton was up. That's why how much? 100 minus 40, 60 you are feeling. So whenever you insert an object inside any fluid, this is a fluid, correct? It experiences upward force, which is called buoyant force, FB. FB or BF. BF I don't write because you will think boyfriend. FB. So this is upward force which is called buoyant force. What is its value? Just value I am writing. What is the value of the upward force? So value of the upward force is density of fluid. Fluid means this fluid multiplied by G multiplied by volume inside, volume of the object inside, VI. Volume of the object inside the fluid means this volume is inside, na? So this volume we have to take. Okay, understood now? So this is the buoyant force. How much upward force will be there? This much, correct? Due to this upward force, the weight of the object, now what we will feel little bit less. So the less weight we call apparent weight, apparent. That is the weight in fluid. Apparent weight is what? Weight in fluid. So apparent weight is nothing but weight in air minus this buoyant force. Suppose weight in air was 100, buoyant force 40. Now net you are feeling how much? 60. 100 minus 40, 60. We have another formula also in the exam, directly you can apply. Apparent weight equals to weight in air 1 minus density of fluid divided by density of solid. Solid means this object which is immersed, and F means density of fluid. So weight, apparent weight equals to weight in air, 1 minus density of fluid by density of solid. Achha. Next, law of flotation. Law of flotation. If the object is floating, see, if the object is floating, what does this mean? Suppose this is the object and this is floating inside the liquid. What does this mean? It means, see, the object is also not going down. It is not going down. It is not accelerating down. Means whatever upward force is there, upward force was what? Buoyant force. And buoyant force should be equal to this weight mg. They are balanced. If they are balanced, then only now it is not going accelerating down. Otherwise, it will accelerate down. So, law of flotation says that buoyant force should be equals to weight of the object. Weight of the object, or mg you can write. This is law of flotation. If it is floating, total upward force should be equals to total downward force. Now, if you solve this, if you put the values, what you will get? Rho 1 V1 equals to rho 1 V1 equals to rho S Vs. I will explain what is this. Rho 1 V1 equals to rho S Vs. Rho 1 is what? Density of this liquid. I am writing density of liquid. Rho 1 is density of fluid. V1 is what? Volume of object. Volume of object inside fluid. Inside fluid. What volume of the object is inside fluid? Means this volume I am talking about. What is rho S? Density of solid. Means object. Density of solid. That is object. What is Vs? Total volume of solid. Total volume of solid. This total volume means from here to here, this total volume. Now sometimes what they give, na? They give two liquids. They have asked in one of the NEET exam. They will not give one liquid. Rather, they give two liquids like this. We have two liquids and the object is floating like this. So suppose here we have water or oil. You think like this, here we have oil and here we have water. So we have two liquids. Density of liquid 1 is rho 1. Density of this liquid is rho 2. Then what equation we can write from law of flotation? Rho 1 V1 plus rho 2 V2 equals to rho S Vs. See, only one liquid was there. Then what we used to write? Only one liquid. Rho 1 V1 equals to rho S Vs. If two liquids are there, so rho 1 V1 plus rho 2 V2 equals to rho S Vs. What is this? Rho 1 is the density of liquid 1. V1 is that volume which is inside liquid 1. That volume of the solid which is inside liquid 1. Then rho 2, density of liquid 2. Then what is V2? That volume of the solid which is inside density 2 equals to rho s. Rho s means density of this solid. Vs. Vs is complete volume. Means we can write Vs equals to V1 plus V2 also. We can write now Vs equals to V1 plus V2. As we know that volume equals to area into height. Volume is what? Area into height. All the places I do area into height, area into height. Area will cancel. Means we can write like this also. Rho 1 H1 plus rho 2 H2 equals to rho s Hs. What is H1? Height of the object which is inside liquid 1. This height of the object which is inside liquid 1. This is H1. What is H2? Height of the object which is inside liquid 2. H2. And what is Hs? Complete height of the solid. Complete height of the solid. Hs equals to H1 plus H2. Remember these two equations. Very, 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 very important. Can be asked in this year. Okay. See, we have one concept, steady flow. Steady flow or laminar flow or streamline flow or streamline flow. You must have seen YouTube videos, laminar flow. Liquid is coming out very layer by layer, very smoothly, like layer by layer. Those are called laminar flow. What is the correct definition? I don't want to go that much depth, but correct definition, what is the correct definition? That at any point, suppose liquid is flowing like this, at any point, the velocity remains constant. This kind of flow is called steady flow, laminar flow or streamline flow. At any point, means at t equals to 0, t equals to 1, t equals to 5 seconds, t equals to 100 seconds, the velocity of point A, is constant. Suppose 10 meter per second. It is not changing. That is called steady flow. Here velocity can change at different point. Different point may have different velocity. But again, suppose this velocity is 20 meter per second. Suppose this velocity is 20 meter per second. Means at t equals to 0, at t equals to 5 seconds, at t equals to 100 seconds, the velocity has to remain constant. Suppose 20 meter per second. Means two different points may have different velocity. Two different points may have different velocity. See, this is 10, this is 20. But with respect to time, their velocity will not change. This is called streamline flow. Opposite to this, just opposite, which does not follow all these. Opposite to this, there is a type of flow which is called turbulent flow. Correct? Turbulent flow. Now there is a factor which differentiates laminar flow and turbulent flow. That factor is called Reynolds number. Reynolds number. It is a number, it is a dimensionless number, Reynolds number. Its formula is DVD. DVD we used to play in our childhood. DVD by mu. What is D? Capital D is dia of tube in which fluid is flowing. Suppose fluid is flowing in a tube. So D is the dia of tube. V is the velocity of the fluid. Velocity of fluid. Small d is density of fluid. Density of fluid. And mu is coefficient of viscosity. What is coefficient of viscosity? Like in solids, if two objects are having a relative motion, they have friction. And friction, what we write? What is the maximum value of friction? Mu into n, where mu is coefficient of friction. Similarly, when liquids are flowing layer by layer, friction is there. So in liquid or fluid, the friction we call by the term viscosity. What we call? Viscosity. And like friction equals to mu n, similarly here, mu, there is mu term which is called coefficient of viscosity. Like in that friction we have now, friction equals to mu n. Similarly in fluids, the friction has some formula, we will discuss later. But this mu is that coefficient of viscosity. Now if this Reynolds number, if you calculate and it is coming less than 1000, then that is a steady flow or streamline flow or laminar flow. Steady flow or laminar flow, whatever. Laminar. But if this Reynolds number is coming more than 2000, then it will be a turbulent flow. And if it comes between 1000 and 2000, it means midway, not proper laminar, not proper turbulent. So you will be given these values, you calculate these values and see whether it is coming less than 1000 or greater than 2000. If it is greater than 2000, it is a turbulent flow. If it is less than 1000, it is a laminar flow. See, then we have equation of continuity. Equation of continuity. What is equation of continuity? It says that if density of the fluid is constant, acha, density constant na means we call incompressible fluid. Density constant means incompressible fluid. What is the equation of continuity? If density is constant, then what we write? Area into velocity value should be constant. Area into velocity should be constant. Acha, area into velocity we call by a term called discharge. This is also called discharge or volume flow rate. Volume flow rate means how much volume of liquid or fluid is flowing per unit time. Volume flow rate. Again I am saying this is also called volume flow rate. How much volume of the liquid is flowing per unit time. This is also called discharge. Discharge we represent by letter Q. Again I am saying Q is called discharge. Discharge is how much volume flows in how much time. Like suppose liquid is flowing, how much volume is flowing in how much time. This is called discharge. Its formula is area into velocity and it is always constant. Why I am explaining this? Because tap problems comes in NEET exam. Tap problems. Tap problems. Now how to solve tap problems? See, they will be giving the tap. There is a tap like this. Okay. You adjust the tap. My diagram is very bad. Okay. Suppose this is the tap. So what happens? You must have seen that suppose water is coming like this. As it falls on the ground, this is the ground. Here this area is broader and here this area is narrow. Now why it happens? What I told that area into velocity is always constant. Or what I can say, area is inversely proportional to, see, I can write la constant divided by this velocity will go there. Area is inversely proportional to velocity. Means if velocity will increase, area will decrease. So see here what happens, whenever a liquid is flowing now, when it comes down, here its velocity will be more. And if its velocity is more, so area will be less. Right? Sometimes we have seen this. Suppose we are washing our bicycle or bike with the help of pipe and water is not reaching the bike. What we do now? We put our finger, means we cover half portion of the pipe or 25% portion of the mouth of the pipe with the help of finger. Now what we are doing with this? Now we will see water is going reaching here. Force becomes more. Why? Because as you decrease the area, velocity will increase. Same here, velocity increasing, area decreasing. What we can write? Suppose here area is A1, velocity of the fluid is V1. Here area is A2, velocity of the fluid is V2. What we can write? A1 V1 equals to A2 V2. So tap problems, you write this equation. And one more equation, you remember V square minus U square equals to 2AS. So this final velocity V2 square minus initial velocity V1 square equals to 2A, acceleration is nothing but G, and S, this is distance, H, 2GH. You remember these two, you will be able to solve all tap problems. All the tap problems you will be able to solve. Then we have problems related to this tube, that water is flowing in a tube like this. There is a junction, means some water goes there and some water is going there. Suppose here area of this tube, area of this tube is A1. The liquid flowing, suppose fluid is flowing V1 with speed how much? V1. Here area of the tube is A2. The liquid is flowing with speed V2. Here area of the tube is A3 and liquid is flowing with speed V3. Now what we can say, see, so whatever water is coming, flowing from here, some water will go there, some water will go there. So what we can say, suppose here total volume is V1, out of V1, some will go there, suppose here some volume goes V2 and some volume is going there, here it is V3. So can I write V1 equals to V2 plus V3? If I divide all the terms by time, so this is volume by time. How much volume is flowing in? How much time? And what I told, volume by time, this is called what? Discharge. Means here if I say the discharge is Q1, here I say the discharge is Q2, and here I say discharge is Q3, I can write Q1 equals to Q2 plus Q3. Acha, what is Q? Area into velocity. Means we can write A1 V1 equals to A2 V2 plus A3 V3. This is very important. I'll take 2-3 minutes more. Venturimeter needs to be discussed. Venturimeter. You must have heard this word, venturimeter. This device does? Venturimeter measures discharge or rate of flow. It measures rate of flow or discharge. This is the device which measures rate of flow or discharge. They can ask in the exam. Okay. Now, how a venturimeter looks like? See. Correct. Here liquid is flowing. Correct. If I focus at this section, section 1, and if I focus at this section, this is section 2. Correct. Just 2 minutes I will take. Section 1 and section 2. So, what we have, that section 1 is broader, section 2 is narrow. So, if its area is more, here velocity of the liquid will be less. Here velocity of the liquid will be high. This I can say velocity, see, area 2 is less than area 1. That's why velocity 2 will be more than velocity 1. You remember one more thing that I will discuss tomorrow. If these 2 points are at the same level, if the 2 points are at the same level, if velocity at any point is more, pressure will be less. Remember like this. This we will discuss tomorrow. If velocity is more, pressure will be less. Means V2 is high, means pressure at point 2 will be less than pressure at point 1. Means point 1 will have high pressure. So due to this, liquid will fill till this height. Liquid will high pressure, na? With high pressure it will go, liquid will fill this height. And this point will have low pressure. So liquid will fill till less height only, because here pressure is less. This distance they called height difference, the difference in height, H. Height difference. Now remember 2 equations and your question will be solved. First, here at section 1, area A1, suppose velocity of the liquid is V1, here velocity is V1, here area is A1, here area is A2, here velocity is V2. So A1 V1 equals to A2 V2, we can write equation of continuity. And one more thing we can write, here velocity will be more, na? Area is less, so velocity will be more. So V2 square minus V1 square equals to 2AS, so 2GH. What is H? This height difference, the top level and this top level. So these 2 equations you have to remember. They ask directly from here. One more thing they ask, because venturimeter task was what? To measure the rate of flow. This rate of flow, Q value. What we get Q value? We get A1, A2 under root of, this value you remember, directly it will save your time. Under root 2GH, when you will solve these 2 equations, you will get this value. A1 A2 under root 2 GH A1 square minus A2 square. So everything you know, A1 is the broader area, A2 is the smaller area. Under root 2 GH, H is the height difference, A1 square minus A2 square. So they ask this also directly. Okay. So rest of the fluids will complete in second shot. Correct? Tomorrow. Till then, enjoy, study, solve questions. Okay? Bye. You should always enjoy, na? Whatever be the condition, life should be enjoying. Okay? Enjoy means not that playing, study and enjoy. Okay?